We'll proceed in tedious calculus problem. Tedious calculus problem that we are solving. The idea is not to solve problem by problem. Idea is to make people view where we need calculus. To view where we need calculus. Okay, can you give example? Okay, so we have clearly said that multiplication, integral calculus is replacement of multiplication. Because integral calculus, there are two approaches in calculating the multiplication. One approach is repeated addition and one approach is drawing a graph, multiplication of two items. If I draw a graph, two-dimensional graph, then we have x-axis and y-axis. Now the two operand of the multiplication. Multiplication is an operator sign and it has two operand, a into b into multiplication is operator, a and b are operands. So one is x-axis, probably b is x-axis and a is y-axis. Then someone draws the graph and then he try to calculate the area underneath it from origin to any point. That way also we can calculate multiplication. This way integral calculus uses to calculate the multiplication, and that is the kind of calculus way of calculating the multiplication. It is also called integral calculus. So multiplication is replaced by integral calculus in a way that graph area is used to calculate the net multiplication. In that sense, what is difference between division and differentiation? Division and differentiation. Okay, if I have, suppose I many times I have given example. What is division? Division is per unit net collection. That is division. Net collection is multiplication. Net collection is multiplication. If person is walking at 5 kilometer per hour, how many kilometer he is collecting in 5 hours? Then it is net collection. How much is the collection per unit time? That is division. Per unit something. Okay, the example repeatedly I have given for this is that consider that I have two bags. In one bag I am putting orange, in one bag I am putting mango. One orange I put in a bag, I put four mango in another bag. Okay, in that sense, I put another orange, another four mango in another bag. Now at the end, I am counting how many oranges are there. Then there are X oranges in this bag. How many oranges in how many mangoes in that bag? 4 into X. Four, four, four. If this bag has four oranges, then that bag has 16 mangoes. How many mangoes I was keeping if I am keeping one orange? Mangoes per orange. Then it is 16 by 4. 4 by 1. Every one orange, numerator, denominator in division. Denominator means every. Every one orange, how many? Numerator. That is the division. Division works well, multiplication works well when it is a numeric constant. It is not algebra. Like if I say I have X oranges, the number of mango are 4 into X, then it is 4x by X, 4. If net result is coming as a numeric, then it is considered as simple division. What are you talking about? Yes, I am talking about if someone dropping one orange, then he is dropping one mango. Consider in this fashion. Like that he keeps on dropping orange and mango. Now when he is counting orange in the bag, then he is seeing there are 10 oranges. Then he is seeing there are 10 oranges. Now he is trying to count the number of mango in the bag. Then he is saying 100 mangoes. Out of 10 orange, there are 100 mangoes. Means per orange there is 10 mango. Now he understood. Per orange there is 10 mango. If I drop one orange, I have to drop 10 mango. Now someone asked him, now count again. Now there are 11 mangoes, 11 oranges. Then now he is sure if there is 11 orange, then as per his calculation, there would be 110 mangoes. When he is counting, it is 121 mangoes. Okay. Now someone asks him count again. Now there are 12 mangoes, 12 oranges. Now someone is asking to count the number of mangoes. Then 12 into 10, 120. But when he is counting 144, now his brain is spinning. Labyrinth, that is a very nice English word, labyrinth. He is in a maze, puzzle now, what to do. He is not able to estimate what's going on. Division means numeric number that is constant. What's going on? Whenever he is counting x oranges, number of mango he is seeing is x square. If there are 4 oranges, the number of mangoes are 16. If there are 7 oranges, the number of mangoes are 49. Here, division will not work. If someone asks how many mangoes per oranges, then someone would reply, I don't know. If someone is very clever, he will reply X. Number of mangoes per orange is X. That no one will understand. What is X? I'm asking per oranges, how many mangoes are there in the bag? X. What is X? I don't know. What is X? This is X. Okay. So there, when the division results, when the division is non-linear, the division is numeric, it is undefined kind of scenario, then differentiation comes into the picture. Differentiation talks about the division only, but at any moment, like when x equal to 11, when orange count is 11, at that time, what is the rate of collection? After all, division talks about rate of collection. If it is a linear, if the collection rate of collection is 4, means every orange someone is dropping in the orange bag, 4 mangoes he is dropping. When rate of collection is dependent upon the number of mango, here when the number of the collection, the what would be the amount that would be present in the bag of mango, if that depends upon the number the orange bag is carrying, then at this point we need differentiation. More orange bag keep, then at that moment the collection of the mango is higher. If number of orange in the orange bag is less, then rate of collection of mango in the mango bag is less. Okay, now please disclose what is the idea here is. Looks like the number of mango and number of orange, they have relationship of x square. If orange is x, the number of mango in another bag is x square. Now, differentiation talks about at any moment. At any moment means when the orange count is x, any x. At that moment, if I add one more orange, at that moment, how many oranges we are adding? This is the division. Anyone would say this is a division, but your division is varying. Division is not constant, it is varying and it is dependent upon x. This is called independent component, that is the orange. And mango is called dependent component. When dependent and independent happens, and then we do the division, when I do y by x, where y is the mango and x is orange, and y is dependent upon x, then it goes for differentiation. So y is x squared. Y is x, the net y, net mango at any time is a square of the orange at any time. What is the rate? Collection of the mango collection is square of orange collection. What is the rate of change? That is the division. If I say mango collection is 20 and orange is 5, mango collection is 24, orange is 6, mango collection, net collection is 28, and orange is 7, then it proves the rate of collection is 4. But when rate of collection depends upon, so rate of collection is 4 means the the y component, that is mango, it is not dependent upon the orange. Y component, that is mango, it is not dependent upon the orange. Okay, if it is constant, if it is not constant and it is dependent upon the orange, at that time we need differentiation. If the net collection of mango is x square and net collection of orange at that moment is x, the rate of collection at any moment is x square by x, that is x. Wrong. That is not true. Anyone can try. Let's try. When orange is 9, at that moment orange is 9, then this bag has 81. At that moment I add one orange. Then how many oranges I am adding? That is the rate of collection. Rate of collection is not the net amount. Rate of collection is if you add one, how much you are adding. That is rate of collection. Okay, if the orange is 9, at that moment if I add 1, main is how much you are adding. I am adding 1. At that moment you are adding 19 to it. That makes it 100. 81, 1900. Means at that moment rate of collection is 19. Okay, it is not x square by x. X square by x means x. That is the rate of collection. When x is 9, at that moment rate of collection should be 9, 10. Near to it, it is 19. Okay, when orange is 10, at that moment if you add 1, then at that moment you are adding 21 here in the mango bag. Means rate of collection at any moment is not that simple division. It is something else. It is considered as reverse of integration. Okay, if I reverse the division, how you reverse the division? If I say I have mango by orange, now reverse this division. If you reverse the division, then numerator will remain. That is called division. Numerator will remain, and that is called reverse of division. Okay, someone would say multiply numerator and denominator, it will become reverse of it, whatever it is. So the kind of, if I reverse the differentiation, then it would become integration. Okay, so if I say that x square division or differentiation with x is x, then reverse of it is the is the integration. Integration of x is not x square. Integration of x is x square by 2. Both are not same. It should be same. Integration is calculating the net multiplication through the area way. So if I say my division of x square with the x is x, then integration should be again x square. Back whatever result is coming as x. If you integrate it with the denominator, multiply again with the denominator, whatever the result is coming, that is x into x dx, integration should result in x square, but it is x square by 2. This proves that the x square, if I have the net collection, I'm not talking about rate of collection, net collection is x square per x, then differentiation, division is not x square by x, it is something else. What it is? Reverse of integration. Okay, reverse of integration. Now, if I have x as a result of division, then integration is x square by 2. If I want x square, then it is actually 2x. If I integrate 2x, it becomes x square, the way I am seeing during the differentiation. This proves that the differentiation of x square with the x is 2x, not x. 2x. Can you prove it? 2x. Okay, we can prove it really. Now let's take x when orange count is 10. When orange count is 10, then you add one more orange. At that moment, you're adding 21 out there. Means 21 is the rate of collection at that moment. I'm saying 2x. X is 10, then it is 20, more or less near. Okay, differentiation says that any moment if you are trying to calculate division, that is momentary division, anyone would say. Any moment, if someone is trying to calculate division, any moment, if someone is trying to calculate division, then we have to see that moment addition of one item brings how many item of addition in the dependent component. If I am saying at a moment orange is 10, then go half back and go half forward. take minus, take 9.5 to 10.5. That is the one chain. Someone can go one chain from the 10 out. If someone goes one chain from the 10, then 10 to 11, one chain brings 21 here. Try 9.5 to 10.5. When it is 9.5, then at that moment, how many it is? How many it is? Then 81, 9.5 means that 9.5 whole square. How much is 9.5 whole square? I really don't know. How much is 9.5 whole square? Okay, let's try little simple. Try it is when x equal to 3. At 3, then we are adding, if I add one more, that will become 3 to 4. Then here, if we will add 7 out here, it will become 16. Now 3, try 2.5 to 3.5. What is 2.5 whole square? 2.5 whole square, I also don't know. 2.5 into 2.5, it will become 125, 5, 12, 24, 12, 36. I believe it will become 2.5, 2.5 into 2.5. 5, okay, 5 and 12 will remain, I believe. 12 into 2, 24, 12, 36, 3.65. But it is not true. The power of 2 is 4. 2.5 into 2.5 would be higher. Okay, so I'll try again. 2.5, 2.5, 25 into 5. That comes as 125. If I keep 5, then 12 is running. 25 into 2, 50. 50 into 12, 6.25. One moment, the moment it is 6.25, now 3.5, one increment I am making, 3.5. 3.5 into 3.5, how much it will be? I don't know. 5 into 5, then 25, 2 will remain, and then 5 into 3, 15 to 17, 175. 175 numerator and 3 now. 3 into 5 is 5, and then 3 into 3 is 3, 10. 105 and 75. 5 and 752. Okay, and then 11. 11.25 or something like that. Increment is seen as 5. Increment is seen as 5. We are saying 2 into x. It is exactly 2 into x. When x equal to 2.5, then if I add 1, that becomes 2.5, half or anything, I don't know how someone would make. Then increment is actually 5, 2x. So the actual division when net collection is x square, the rate of collection at any moment, every moment rate of collection is changing. Any moment when orange count is x, at that moment rate of collection is 2x. That is the difference. That is the difference between division and differentiation. Division talk about rate of collection when rate of collection is constant. Otherwise, it would start varying depending upon the independent component. Whereas differentiation talk about rate of collection at any moment. If I have x-axis and y-axis, at x-axis I have a pointer that is x. At that moment, what is y? Now, if I increment 1 unit, then how much y would change? That is y dy by dx, delta y by delta x. Or if I am taking point x, then x minus delta x by 2 to x plus delta x by 2. Again, it is delta x. Then how much at x minus delta x by 2, what is the y? And x plus delta x by 2, what is the y? See the change in the y, delta y by delta x. That is at any moment x. What is the change in y I see when there is 1 unit of change? That is differentiation. So when we talk about algebra, better go blindly with the differentiation. If it is numeric, the differentiation will result into numeric. Dy by dx, if rate of collection is, if collection is 4x, and then mango orange is x, then d of 4x by dx is actually 4 only. That is same as division. So division is subset of differentiation, and integration is Division is subset of differentiation and multiplication is subset of integration. So blindly take use integration, blindly use differentiation. Like vector is superset of algebra. So calculus with the vector is everything. Anyway, we will do some one. I will going to take one example. Okay, we'll do surface area of the sphere later on. So what example I am going to take? Consider I have a battery. This is really a battery. This is 3.7 volt battery. Hope, it is tightened. There are two batteries. There are two batteries, and these are say 3.7 volt lithium. Hope this is lithium ion battery. Okay, very powerful battery. It is around, I believe, 600 milliampere hour battery. 600 milliampere hour battery. What is the wattage of the battery if it is 600 milliampere hour? This is 3.7 volt. Means 3, if it is 600, I don't know it is 600 or not. 500, 500 milliampere. The specification of the battery is it is 13350 type of battery. It is 3.7 volt battery and it is 500 milliampere hour battery. Okay, what is the wattage of this battery? One battery. There are two batteries. Okay, I have done the soldering of it. So there are two batteries. Okay, we will do calculus on it. So idea is doing calculus on the batteries. Okay, this is the battery. Okay, very nice. Now, one battery is 500 milliampere hour. What is and 3.7 volt? What is the wattage of one battery? People generally ask what is the wattage. What is 300 milliampere per hour? Means if I use this battery for 1 hour at 3.7 volt, 3.7 volt the target is taking with 3.7 volt, this battery would provide 3.7 volt at 3.7 volt. When this battery is providing for 1 hour constant 500 milliampere of the current, it would release. That is 500 milliampere hour. If I use this battery, I really have resistance. Okay, this is a set of resistance that I am using. This is 320 kilo ohm, but I will not connect it because for integration I don't have multimeter. I have multimeter, but anyway, this is resistance. This resistance is 220 kilo ohm. This resistance is 220 kilo ohm. Consider that I am connecting this battery, I am connecting this battery to this resistance. Then at 3.7 volt, then it will start drawing current. Consider, for God's sake, it is withdrawing current of 500 milliampere only. 3.7 volt by 220 kilo ohm, I don't know how much it will be. Okay, consider that there is a some kind of calculation. Okay, idea is 500 milliampere, right? 500 milliampere is zero point 0.5 ampere. Zero point 0.5 ampere. If 3.7 volt is there, 3.7 volt is there, then how much should be the resistance? Then R equal to 3.7 by zero point 0.1. Zero point 0.1. Then R would be 37 ohm. If I take 37 ohm resistance and I place 3.7 volt battery, then it will start drawing point. I'm sorry, that is zero point 0.5 ampere. 500 milliampere is zero point 0.5 ampere. Okay, zero point 0.5 ampere means 3.7 by zero point 0.5. Then it will double it. 7.2 ohm. 7.2 ohm if I take a resistor and if I take a battery that is 3.7 volt battery, then this resistor would withdraw 500 milliampere. It keep on drawing 500 milliampere current at 3.7 volt voltage. Then for 1 hour, this battery can supply, if it is fully charged, 1 hour it can supply for 500 milliampere. What will happen after 1 hour? It will be exactly zero. That is the strength of the battery. If you withdraw 500 milliampere of the current from it at voltage 3.7 volt, then it will go for exactly 1 hour. Beyond that, it will be exactly zero. This is the power of the battery. Anyway, now consider, okay, I have many other things. I have a capacitor. Okay, I have a capacitor. So this capacitor is 25 volt capacitor, and it is 330 microfarad. It can operate at 30 volt, 25 volt, and 330 microfarad is the capacitance of this capacitor. I have other capacitor also. I, I believe this is also a capacitor. This is a capacitor. And then I have a kind of a transformer. This is broken leg transformer. This can behave as an inductor also. Okay. And then I have a diode. I have many things. Okay. I have full-fledged electronic equipment. I have a different kind of inductor. This is also an inductor. I believe it is visible. This is an inductor. Anyway, now idea is, consider that I have a RC circuit. I have a RC circuit in the sense I have a capacitor, and capacitor is connected to resistor. Okay, this capacitor, this capacitor is connected to this resistor. Okay, this is the resistor, this is the resistor, and this is capacitor. They are connected in series. Okay, I am going to connect it. Okay, connected. This capacitor and resistor are there connected in series. Now, now consider that I am, I am really connecting it now. Now I am connecting it to the battery. This is the battery, and I am going to connect to it. Okay, now it is visible that capacitor, oh, this is hot now. Okay, so this capacitor and resistor, they are connected in series, and they pull in series only, they are connected to the battery, 3.7 volt battery. Okay, now this is the loose end. Now I am touching here. Okay, this is the connection. Now, if I'm connecting this, how much is the current that is flowing? That is the question. If I connect the resistance directly to the battery, then at same moment the current would start flowing. But that is not true with the capacitor. If resistance and capacitor, they are connected in series and they are connected across a voltage source. Consider the voltage source is Vs, the voltage source is Vs, and then resistor is R, and capacitor has capacitance as C. The question is arising, what is happening? That what is the nature of capacitor? The capacitor has a nature. The capacitor has a nature. If I attach a battery source to the capacitor, then immediately the infinite current would flow through the capacitor. It behaves like a closed circuit. It behaves like a wire without any resistance, zero resistance, like a connected circuit. A huge current would flow through capacitor immediately. Then capacitance, on the capacitor plate, in capacitance there is a two plate. The voltage across plate will start developing. This capacitor will start storing electrical charge time to time. And one moment will come that capacitor will store that much energy. Capacitor is an energy storage device. Resistor is not an energy storage device. So if I place a capacitor against a battery, then initially there is no energy stored in the capacitor. Current will flow as if it is flowing through a copper wire. And then slowly capacitor will start storing the energy in the form of electrical charge. One moment will come that charge, it will store a charge to some extent, it will start behaving like a battery. Battery in the sense that current would not flow. If I have attached a voltage source of 3.7 volt, then around the capacitor, the voltage will be formed as 3.7 volt. Now I can disconnect the capacitor. Now voltage across the capacitor is 3.7 volt. It is behaving like a battery now. If I connect this capacitor across any LED or something, I would try to do. I had LED source or LED also. If I connect this capacitor across any LED and after getting it charged through battery, LED would glow. But slowly, it is not a constant voltage source, right? Then LED would dim because charge is dissipated in the LED. That is the concept of capacitor. Now, this proves that the any moment current flowing through the capacitor is not constant. If voltage source is constant, but current flowing through capacitor is not constant. At the beginning, current is very high, and at the end, there is no current at all because it will block the current when it is fully charged. Now, idea is when I have a voltage source and I have it is connected to a resistance and it is connected to a capacitor and connected it back, then then at any moment, what is the current that is flowing through this path? That is the question. Question is straightforward. At any moment, what if I connect a resistor across a voltage source? What is the current flowing at any moment? That is constant. That is voltage by resistor. Because current is constant. Moment you connect, current will start flowing because resistance is constant and resistor is not an energy storing device. But if you can take a voltage source and capacitor and then you connect, at the beginning there will be sharp rise in the current. Then slowly current would start decreasing and one moment current will stop. What is the current at any moment? Now, if someone is integration guy, then he will say, looks like time is independent component and current is dependent component. Current is dependent upon time. Every time current is different. If x-axis is time, then y-axis is current. At the beginning, when time is zero, then it is origin. At the beginning, the current is very high and then slowly current is falling. There is a time comes when current is zero. At what time current is zero? Now that is the question. At what time the current will be zero? At the beginning, what is the current at the beginning? Okay, then at any point of the time, what is the current? That people would ask. Okay, that is the scenario. Then what is the formula that I believe it is? Much of the discussion happened. We'll try next session. Calculating the current voltage at any moment across the capacitor. Amazing, mind blowing. This falls in calculus because we will have division and multiplication, but we have algebra because we have time. Algebra in the sense that we do not have numeric. We have algebra means we have something in variable. Time is variable and voltage across capacitor is dependent upon the time. That the current across this full circuit is dependent upon the time. When independency comes into the picture, then all the multiplication will be turned into integral calculus. All the division will be turned into differential calculus when we have division of algebra by algebra where denominator is independent and numerator is dependent. This you cannot get through modern calculus. This you can understand only through primitive calculus. You can watch our primitive calculus video, series of primitive calculus video. Anyway, we will proceed on this. Please do not mind supporting us. +91 is the India country code 94831 60610 is the telephone number. +91 is the India country code 94831 60610 is the telephone number.